3. Characteristics of radioactive decay. Radioactive decay is random in nature. The following experiment uses a dice analogy to simulate this decay process. Experiment 2A. Radioactive decay, a dice analogy.
Here are 100 dice. Throw them in a large box. Remove all the dice with side 1 facing up. Count and record the number of dice removed and the number of dice remaining in the box. Throw the remaining dice again. After removing all the dice with side 1 facing up, count the dice again. Repeat the throw until there are only a few dice left in the box. By plotting a graph of the number of dice remaining against the number of throws, we obtain the decay curve of dice.
The number of dice decreases after each toss. When those give 1 are removed, the decay curve of dice remaining is shown on the next page. The dice remaining in the tray represent undecayed nuclei. So the number of undecayed nuclei in a radioactive sample should also decrease according to the similar decay curve. And such decay is called exponential decay, while the curve drops faster if the probability of decay is larger. A. Random nature. Although dice tossing is random, that we are not sure which and when a dice will give a 1. We know the probability to give a 1 is approximately 1/6. So the number of dice to remove, which represents the number of decaying nuclei, is given by 1/6 multiplied with the number of dice remaining. B. Activity. When radioactive nuclei decay, there is radiation emitted. The number of decay per second is called activity, measured in becquerels, or decays per second. As there is a certain probability that a radioactive nucleus decay, so for a radioactive sample, the activity A equals K multiplied with the number of undecayed nuclei, where K is the probability of decay per unit time. So what's the difference between activity and count rate? Activity is always due to radioactive source, and it does not include background radiation. And for count rate, we use a GM tube, and the GM tube can only receive part of the activity from a source, and it usually includes background radiation as well.